Back in those, let's take another look at our TSR program. The last time we were discussing how calling a DOS function to free memory here is not truly safe, because then the return portion of the interrupt would be executed in memory that has already been freed. So the way we dealt with this is to make the uninstall function return the value of segment to free, and then the program that called it needs to free it here. This is the function to free memory. But what if we wanted to have this function be able to uninstall the TSR without shifting responsibility to the caller? What if you wanted TSR to be able to uninstall itself without any assistance? We should then use some tricks. One possible trick would be to move this epilogue into a place in memory that is safe. But this again would be a possible interaction with other DOS programs, because any memory that is not free for DOS has probably some use, or even if it does not have one, then another DOS program may use it the same as we would use it. So this is probably also not a safe thing to do. But another trick we could use is what I said last time, that we could jump to interrupt to one vector directly and let this vector return from the interrupt to the caller, skipping us. And I said that we cannot do this because we need to restore registers too. But there is a possibility that we can just document our function as destroying a bunch of registers. As I also said a couple of times, in those days it was usual to document every function in detail, what registers were preserved and which ones not. So we could just say that this function destroys these two registers and not care. Because we did push them here, we need to restore them anyway. But then we are going to prepare the jump. We need the S0, so let's We can pop them both or adjust SP register perhaps. Let's leave it at pop. Pop register is a short opcode. This should be just 2 bytes. Then DS is still 0, so finally we can jump to DS to 1 times 4 as a far double word. We could also restore STI interrupt stack here, just in case DOS function needs it. In general, when you clear interrupt stack inside interrupt handler, you do not necessarily need to restore it, because iret is going to restore it when it is restoring flags from the stack. Therefore, we do not need to this one. We do not need to free memory here. TSR should be able to uninstall itself. We just have to remember that this function now destroys DS and ES registers, but we are setting up DS later anyway, so this does not do any harm here. Well, I believe this should work. Let's try it. This is the one that I modified, right? Right. We have a fast clock now. TSR in memory. And let's try removing it. Has been uninstalled. The clock is slow. And is memory free? Yes. So it worked. This did the trick. So after all, it is possible for TSR to uninstall itself cleanly, just with some additional assumptions that this function that uninstalls it destroys some registers, segment registers. Hello everyone, thank you for coming. Yesterday I was also showing this reprogramming of palette. But this was just for our own graphic program. And since I'm demonstrating how in DOS you had access to everything and and any program could break things for any other program, then I should perhaps show how this reprogramming of VGA colors could affect other programs as well. Not only in graphic mode, but in text mode too. So let's make another copy of this program. And do not set up graphical mode this time. The text mode uses only 16 colors, the initial 16 colors of this table. We should perhaps make it a bit more compressed. So that shades of colors within these 16 colors change more quickly. And let's try it, assemble and run. So running this little program has affected our entire editor environment. The colors in text mode are changed as well. And if we return to shell, the colors stay altered. So this also demonstrates how any program in DOS could reprogram some hardware and make things different for other programs as well. To get rid of this, we could switch to some different mode. And now colors are back to normal. In a similar manner, you could change text font used in text mode. And I have this little program here, unfortunately without source codes. This is one of my very early programs for DOS, written back in 1997. And it was able to load some fonts in text mode. This is a TSR. It hooks interrupt 10. And because this is a TSR, then the font alteration does not go away even when we switch modes. The other mode uses 8x8 pixels font, so this one is not changed. But when we switch to any mode that uses 8x16 pixels font, then the font stays altered. This TSR ensures this. We can switch. We can even switch to graphical mode and back. And font stays altered until we remove the TSR. So this was all a demonstration how in DOS it was like a Wild West, where every program could mess around and modify everything, modify any place in memory, even if it belonged to other program, access any hardware directly through I/O ports. And I think that we could now establish that we have seen enough of this Wild West programming of unprotected mode, as I called it. So next week I would like to show you some protected mode programming, and perhaps from the very beginning. So again, we would start here in real mode DOS, but we would try to set up protected mode and see what it offers.